In this video, we are going to look at the examples from the 12.3 slides. We're starting with this problem. We want to find the ranges of these distributions. Ranges are pretty simple. All we need to do here is to take the largest value and subtract the smallest value. So the range for distribution A here is 9 minus 4 equals 5. Likewise, for B, we take the largest value, subtract the smallest value. 13 minus 1 equals 12. Next, we are asked to find the derivations from the mean for all data values in this sample, 32, 41, 47, 53, 57. The mean here is 46. And the derivations from the mean are just the differences between each of the values and the mean. So we take 32 minus 46, and that gives us a negative 14. 41 minus 46 is negative 5. 47 minus 46 is 1. 53 minus 46 is 7, and 57 minus 46 is 11. There are our derivations from the mean. Next, we're asked to find the standard deviation for this sample. We've got a sample that has 7, 9, 18, 22, 27, 29, 32, and 40. The formula for the standard deviation is S equals the square root of x minus x bar squared, x minus x bar being the deviation from the mean, divided by n minus 1, where n is the number of elements in this set. So here, n is 1, 2, 3, 4, 5, 6, 7, 8, and I am not going to bother to calculate the mean here because you guys know how to calculate the mean. The mean here is 23. So we're going to find the derivations from the mean. We'll add them all up, we'll square them, add them up, and then divide by n minus 1 and take the final square root. Okay, so we've got 7 minus 23 gives us negative 16. 9 minus 23 is negative 14. 18 minus 23 is negative 5. 22 minus 23 is negative 1. 27 minus 23 is 4. 29 minus 23 is 6. 32 minus 23 is 9. 40 minus 23 is 17. Okay, now we square each of these. So we'll just take this and do x minus x bar squared, x minus x bar, and then here we'll take x minus x bar squared. Okay, negative 16 squared, that gives us 256. Negative 14 squared is 196. Negative 5 squared is 25. Negative 1 squared is 1. 4 squared is 16. 6 squared is 36. 9 squared is 81. And 17 squared is 289. And when we add these all up, we get 900. Finally, well, next to finally, we divide this by n minus 1. N is 8, so n minus 1 is 7. That gives us approximately 128.57. But here is an important thing. We should not take the take that value we should not round and then take the square root. We should take the square root before rounding. So I'll just take my calculator, which is my iPhone calculator, of course, and I'll put in 900 divided by 7 gives me 128.57, et cetera, et cetera, et cetera. And then I'm going to take the square root of that, and I get 11.3389, et cetera, et cetera. So when I take the square root of 900 over 7, I'm going to round that to 11.3, and there is our standard deviation. For this next problem, we want to find the sample standard deviation for this frequency distribution. We've got values of 2, 3, 4, and 5, and frequency and related frequencies of 5, 8, 10, and 2. We know how to take the mean. I'll just give you the mean is X bar equals 3.36. So for things of this sort, we're going to find our deviation from the mean and square it, and then we multiply that by the frequency. And then we add up the squared derivation times the frequency and divide by 24. So 24 being the total number of items in our frequency. 5 plus 8 plus 10 plus 2 is 25. So 24 is that minus 1. So we get two minus 3.36. This is going to be X minus X bar. That is negative 1.36. 3 minus 3.36 is going to be negative 0.36. 4 minus 3.36 gives us 1.64. 5 minus 3.36 gives us 2.64. Now we will, so those are our deviations. Now we'll square them. Okay, and that's going to give us 1.8496, 0.1296, this should be 0.64 and 1.64 there. 0.4096 and 6.6896, 2.6896. There we go. Next, we'll take F times X minus X bar squared. Just put that there. So sorry, it went through the line. We've got 9.2480. 1.0368, 4.0960, and 5.3792. And when we add all of these up, we get a total of 19.76. We divide, we've got, we take square root of 19.76 over 24. This is going to be S. And we get 0.91 approximately. Next, we're doing some work interpreting our measures of dispersion. Companies A and B sell 12-ounce jars of instant coffee. 5 jars of each were randomly selected from markets, and the contents were carefully weighed with the following results. We've got these 5 weights for Company A and these 5 weights for Company B. We're asked first, which company provides more coffee in its jars? Well, the first thing we're going to do is we're given the values of X bar and S for each of these companies. And we'll just write this down here. So for Company A, X bar is 12.008. And S is 0.05455. And for Company B, we've got X bar is 12.292. And S is 0.0847. Okay, so we are asked first, which jar provides more coffee in its jars? And clearly, well, we're talking about fractions of an ounce here, but Company B consistently provides more coffee in its jars. The second question asks, which company fills its jars more consistently? Which company has closer values? Where are the jars almost the same weight? Well, that is going to be Company S, because a smaller standard deviation suggests more consistency. However, I'd still go with Company B because they get more coffee in their jars. Now we're talking about Chebyshev's theorem. We're asked, what is the minimum percentage of the items in a data set that lie within 3 standard deviations of the mean? Well, that means we've got this formula for Chebyshev's theorem. 1 equals 1 minus 1 over k squared is the minimum fraction within k standard deviations. So here k equals 3, so we've got 1 minus 1 over 3 squared, or 1 minus 1/9, which is 8/9, or approximately 0.8 repeating. Okay, well, that's about 89.9 or 88.9%. Last question. We're asked to compare the dispersions of these samples A and B. We are given we're given 3 values for each of these. We're given X bar, S, and V, the coefficient of variation. So X bar for sample A is 16.167. S is 3.125. and V is 19.3. For B, X bar is 153.167. S is 25.294. And V is 16.5. So the question is, we want to compare these dispersions. We get these values we get these values when we make all these calculations. The important thing to know is that B has a smaller, B has a larger dispersion, but it's also dealing with much larger numbers. It has a smaller relative dispersion. Related to A, B is dispersed a lot less. All right, that's it for this video. If you have any questions, please get in touch.